This is Geometry, Lesson 10.5b, Trigonometry and Area. So the goal of this lesson is that you'll be able to find areas of regular polygons and triangles using trigonometry. Now, we talked about regular polygons already, so this is going to focus on finding the area of triangles using trig. So first off, we can use trigonometry to find the area of a triangle when you know the length of two sides and the included angle. Now, the important thing is that you understand that this included angle is not a right angle. If it was, we could use our basic 1/2 base times height, but we have lots of triangles that are not right triangles or don't have an altitude drawn in, so this is a way to find the area of a triangle when you don't have those things. So here we've got this picture. So suppose you want to find the area of this triangle, but you only know the measure of angle A. Angle A is over here, and you know the lengths of sides B and C, the attached sides. Angle A is the included angle between those. So if you're going to use your basic formula 1/2 base times height, you would need to know the height. And so what we're going to do is we're going to actually write a proof for this other formula that kind of talks about how you find that height and use trig to find it. So our sine ratio for angle A, if we draw in this altitude for the height, it's opposite over hypotenuse, so it would be h over c. So sine of angle A equals h over c. Now, in this case, we don't know the height, so we're going to solve that for the height. So we multiply both sides by c. We get that the height is c times sine of A. And so what we can do then is we can take this c sine of A, which is another way to write the height, and we can plug it in for the height in our area formula. And so we get this new area formula. 1/2 base times height turns into 1/2 b c sine of A. Because this c sine of A right here is actually the height of our triangle. Now notice that they are using three different variables in this formula, B, C, and A. B and C are always going to be two adjacent sides, and A is always going to be the angle between them to use this formula. And so if you were doing a proof, this is the proof for why this following theorem works. Now this works only when angle A is acute. If you were trying to do this when A was a right angle or obtuse angle, it's not going to work quite so well. So here it says theorem 10a, area of a triangle given side angle side. The area of a triangle is half the product of the lengths of two sides and the sine of the included angle. So in this case, if it's 1/2 BC sine of A, it would be side B, side C, and angle A. So we go 1/2 whatever B is, whatever C is, and side of angle A. Now we're going to use this formula in order to find the area of this triangle. Now we know we can use 1/2 BC sine of A because we have a side, 21, another side, 12, and we have the angle 48 degrees between them. So the formula is 1/2 BC sine of A. And so we take these parts, and it helps to label them, I find. So 21, let's call that B. 12, let's call it C, and then the angle is A, it's 48 degrees. And we just take those and we plug them in. So for B, I'm going to put in 21, C 12, A 48, and we get 1/2 21 times 12 times sine of 48. And so what I want you guys to do now is type that in your calculators. So once you've typed that in, you will get a decimal, a continuing decimal. We get something close to 93.636. So in this question, it does not tell us what to round our answer to. If it doesn't, let's round them to the nearest tenth. That's one place after the decimal. So we look at this 93.636. Well, we're going to terminate it after the 6. So we look at the 3. That tells us it's going to stay at 93.6. And don't forget your label, centimeters squared. Okay, so it's pretty straightforward. What I'd like you guys to do now is try this other problem on your own. Pause the video and then you can check your answers. Okay, so we're going to use our 1/2 BC sine of A, like we said. We label all of our parts. We've got B, C, and A. We plug them into the formula. 1/2 1610 sine of 34. Type that all in. You should have gotten about 44.735. They didn't tell us what to round to, so let's round to the nearest tenth in this case. Don't forget your label as well, and we end up with 44.7 inches squared. It's pretty straightforward. It's just identifying what parts to plug into the formula where. Always make sure that the angle that you use is included, so that means the two sides make that angle. If you had a different angle, like the one way over here where my cursor is, or the one up top, you would not be able to use this formula and you'd have to do something else. So this is the end of section 10.5, which is all about area of regular polygons and triangles using trig.